Good evening, everyone, and welcome to today's webinar titled The New Space Economy, Malawi's Future to Uphold. Brought to you by Daka Space Technologies under the Malawi Space Stars initiative, supported by the Royal Academy of Engineering through the Frontier Champions Grant. My name is Patricia Garcia Banaba, and I'll be your host for this amazing session. Please be noted that this meeting is being recorded for record keeping. With Africa's new space economy flourishing, we are so thrilled to see Malawi playing a vital role of development. In this session, we explore the potential for Malawi to thrive in this new era of exploration. We'll also make this highly interactive session, so feel free to submit your questions in the Q&A box provided. The speaker will address them during the dedicated Q&A session later after his presentation. For engagement, you can also share your thoughts, questions on our social media platforms using the following hashtags: hashtag DST, hashtag TMSS, and hashtag NewSpaceEcon as shared in the chats. Finally, we invite you to join the Malawi Space Stars community by clicking the link that is in the chats as well. You can also follow our social media pages for the latest updates. Without further ado, I would like to introduce our speaker, Chisomo Daka, the most influential man in digital transformation and innovation in Africa. Mr. Daka is a true visionary and a technical leader in Africa's burgeoning space industry. As the founder and CEO of Daka Space Technologies, the very first kind in Malawi, Mr. Daka is a pioneer bridging space technology expertise to the continent. He holds a PhD candidacy in physics alongside an impressive academic background, including master's degree and certifications from prestigious institutions like the EPFL and International Telecommunications Union. Mr. Daka's influence extends beyond his company. His passion for space exploration is evident in his advocacy work. Through his initiative, the Malawi Space Stars, he's inspiring a new generation of African scientists and engineers to reach for the stars. Additionally, Mr. Daka works with the Malawi University of Science and Technology, MAST, as a lecturer in physics. Today, Mr. Daka will be sharing his insights on the new space economy. Let's all learn, engage, and explore the exciting possibility of the new space economy in Africa. So please join me in welcoming Mr. Chisomo Daka as he takes the floor.
Good evening, everyone. Good evening, dear audience. Thank you for your time to attend to this event. It is a great privilege and an honor to engage with you at this point in time. So a lot has been said about me. I'll have to go straight to the presentation today, which is titled The New Space Economy, Malawi's Future to Uphold. But just to go through what Patricia said, I am the founder of Daka Space Technologies, and we've been operating in Malawi for the past 1.5 years. It's a baby company, and at the same time, I am also interested in science and technology innovations. That's one of the things that gives me motivation and thrills my passion to engage in space science and exploration. So I'll just quickly get you guys through the contents of what we're going to discuss today. We'll start with a brief introduction where we talk about who we are as Daka Space Technologies and also introduce a little bit of the Malawi Space Stars. And then we'll look at the new space economy. But based on the feedback that I got from the Google form, I think I'll start discussing the new space economy with a little bit of background, knowing that some of the participants are students who are interested to know a little more about space. And then we'll look at the context of space in Africa, and then we'll finalize our talk by looking at space applications, mainly looking at what are the use cases and satellite applications that can be leveraged for socio-economic development. So let's get started by looking at the introduction. So you see, in December of 2022, I published an article in the news titled Space is the Next Big Thing. And it came along the time that I was recognized as one of the most influential men in digital transformation in Africa. And you see, when you have these kind of conversations at a global scale, you realize that a lot of people really believe and think that Africa is indeed the next big thing. And more precisely, in my context, I feel like space technology is among the next big things in Africa. So our story started way back when I was a master student in India. We had a team where we were looking at deploying a cube satellite in space. And I happened to have led a team that was developing a laser payload. So we were looking at high frequency paced laser that we could use to map space debris and stuff like that for space, space environment monitoring, collision avoidance, and many other things. So when I got back in Malawi in 2022, I then wrote a business model to start the first space technology startup in the country. So we are a visionary institution as Daka Space Technologies, and we want to be the industry leader in the advancement of space technology in Africa and beyond. And we are calling space technology quantum leaps because we want to take flock jumps. We don't want to take baby steps. We want to achieve better things within a short time frame. And our mission is mainly to develop innovations that can be sold to governments, businesses, and consumers. So for that, we are tasked with the great task to reach for the stars. We want to provide the greatest solutions to mankind. So as a corporate entity, our core values include big thinking, and we mainly believe that our solutions have got to be competitive within the continent as Africa and also at a global scale. And we also believe in innovation. Our youngsters are developing quite creative innovations at Daka Space Technologies. And we also believe in excellence, quality, integrity, and collaboration. So our value proposition has been simplified into 4 distinct points to say. Firstly, we would love to deploy and operate the next generation of high-speed space networks. In this case, we are looking at the future of 5G and 6G communication in Africa. And then we also would love to set up efficient spacecraft manufacturing facilities. So what we want to do is that we want to be able to design, simulate these spacecrafts, and at the same time map an assembly line in manufacturing these equipments and testing them to qualify for space deployment. So we would also want to be a leading entity in cutting-edge space research in Africa. And as you will notice in a few slides down the line, there's very few entities in Africa who are focusing on private space research and development. Most of the research is being done by usually government institutions like space agencies or academic institutions. And then I would also love to develop out of this world innovations which are affordable to everyone. So maybe you may ask, what is it that we do? I've just taken some screenshots of some of the works we're doing. I've removed most of the important details to safeguard our intellectual property. But you can see from the very left there, that is our Cube satellite. And we have just demonstrated the structure, and we're simulating the final design on the structure and materials that are going to be embedded on that one. And then on the very middle there, we have got the cold gas propulsion system that we want to deploy in these small satellites in order to enable near real-time collision avoidance systems in space. As you may be aware, a lot of deployments are being done in space, and there's a lot of garbage in space. We call it space debris. And then one of the things that will enable us to have a sustainable space environment is to have mechanisms to navigate through debris. And the bottom right, I've taken a small depiction of our novel 5G phased array antenna. You see, these days technology is advancing, so we are also advancing with technology in order to enable these satellites to have the best 5G communication systems that can be embedded for 5G communication. Because by the end of the day, we also want to be involved in communicating in rural and remote areas where terrestrial networks do not operate properly. So we are an open house. We collaborate with people in different fronts. And one sort of collaboration that we have is through grants, funding, and investment. And the Royal Academy of Engineering that has supported us right here has supported us through a grant. So we have made some sort of collaboration through a grant. And for investors and many other stakeholders, we have some sort of investment plans that we discuss and collaborate with. And we also collaborate with institutions that are advancing space research and development. So we can collaborate with universities and also with research institutions. At the same time, we are tasked to advance space knowledge in Africa in general. That's why the Royal Academy of Engineering is supporting the Malawi Space Stars, that will bring it down to classroom, to youngsters in schools, so that they understand that there are potential careers that needs to be reverenced in order for Africa to advance in the new space economy. So maybe at this juncture, one would be asking, what is our end game? What is it that Daka Space Technologies wants to achieve? Well, you see, in a few words, I would say that we want to be a one-stop center of excellence in space technology. would love to do everything space in Africa. So would love to work with African space agencies, big corporates, startups, and many other stakeholders in the space industry. At the same time, our excellency has got to be extended all the way to our abilities because we want to be able to design space missions and operate space missions in Africa. And at the end of the day, we also want to be part of the African community that is advancing space education and awareness and also conducting cutting edge research. So just a glimpse about the Malawi Space Stars. You see, the Malawi Space Stars is mainly aimed at inspiring the next generation of space technology leaders in Malawi. We want to stimulate curiosity in the mindsets of youngsters so that they can look at potential careers in space as they grow and as they think about their future endeavors. And this initiative has been supported by the Royal Academy of Engineering, and the grant was given to me in December 2023. So, with that brief introduction, let's now look at the new space economy. However, I think for a start, we can start to talk about space because a good fraction of the audience um, need to understand the context of space itself. So you see, every time someone talks about space, it's not the space that you think is in your house at the living room or in your private bedroom. All right. Yes, indeed, we can say that is airspace, but the space in this particular context is what we call outer space, which is the space beyond the atmosphere, beyond the blue skies. Okay. So because we do not always want to say outer space, so we just shorten the word outer space to space. But what we mean is that we're talking about the space outside the atmosphere. So just in case some students are curious, let's just look at what is it that one can see and find in space. You see, space is very, very empty, okay? It's pretty much vacuum, okay? And for that reason, it is very, very cold. And the average temperature of the universe, correct, of which a good fraction of it is empty space, is approximately 2.7 kelvins, which is about 270.45 centigrades. And at the same time, in space, we have what we call hills and valleys. And these are nothing but gravitation fields. I do not want to talk more about it because there are two schools of thought on gravity. You can either think about the Einstein relativity explanation or think about the classical Newtonian understanding of gravity as a force. But anyway, uh, gravity is in this case at play in space, and every time things are moving through space, you may meet objects with high gravitational attraction and other objects with relatively low gravitational attraction. And also in space, there's great deal of radiation. You see, in our immediate home, in our solar system, we have solar flares coming from the sun. And beyond that, we also have the cosmic radiation that is hitting on us from every corner of the universe. So there's all sorts of things happening in space. So at this point, a typical student will rather be asking themselves, what is it that may kill them first if they travel to space? Probably this is something that you can keep it as food for thought. So let's progress by looking at what else is out there in space. You see, our home, the Earth, and our natural satellite, the Moon, is our immediate environment that we have well been accustomed to ever since we were born. But beyond the planet that we live on, we are existing in an ecosystem of planetary objects. We call that the solar system. And then beyond the solar system, you see that we are also existing within a galaxy, which is a collection of stars and so many other things in it. The Milky Way is our home, so to say. And then these are the natural things that we know they are in space: the sun, the planets, the galaxies, the moon, and everything else. But also, mankind has advanced ingenuity and technology to an extent that we have started putting things in space. The nearest big objects we have in space include the International Space Station, which is just about 400 kilometers above the Earth's ground. And then just recently, NASA, the European Space Agency, and the Canadian Space Agency, and many other stakeholders put up a novel telescope in space at the Rangarajan 2, which is about 1.5 million kilometers away from the Earth. You see, this is a novel telescope that is giving us other insights about the universe we live in. But beyond that, you see at the bottom right corner there, we have what we call the Voyager 1. This is the furthest man-made object that is away from the Earth. It was sent back in time, and it has gone so far, close to beyond the boundary of the solar system. But let us look back in time and see how did things start. You see, space exploration is quite an odd story. And if we put it to better context, I think I'd say people started to get fascinated about what is out there way back in time. You know, in the times of Nicholas Copernicus, in the times of Galileo Galileo, in the times of Isaac Newton with his a mirror telescope, and so many other genius minds came into picture in order to think about what was out there in space. But of key importance is what the Soviet Union, today we call the Soviet Union Russia, or the modern day Russia, uh, is believed to have ushered this new space age by launching the first satellite into space in 1957. So, this is a point in time that we, as the new generation of space explorers, think about it as a turning point for the modern day space exploration. And you can appreciate the Sputnik at the very bottom left corner there. There's a scientist touching it, and there's another picture just suspended in air or in space. So this particular launch was really groundbreaking to an extent that it is believed that the US government was caught off guard. I'll say a little more about it in the next slide. And then it took a few more years. It took a few more years for a few more months rather, for the US to launch their own satellite in the next year, 1958. So, why is it that the Sputnik caught the US government off guard? Maybe someone might be wondering. So, the thing is that back in the days at that point in time, the US government and the Soviet Union were competing pretty much on many fronts. Okay, and that is what we call the Cold War. Each side wanted to be the best at something. They wanted to be the best and the first at everything. So much so that that should have been understood as some sort of superiority against the other party. So the US and Russia wanted to show some sort of superiority on the global playground. So the space race was ideally the race between these two superpowers. At the same time, when this was happening, they were also competing on other technology advancements, all right? And that gave rise to some tensions in terms of proliferation of nuclear weapons and also advancements of nuclear power plants, which were mainly aimed at producing plutonium for that could have been used in uh, nuclear bombs and many other things. So that race went on, and but one of the most remarkable things is that out of that race, the U.S. agency that looks after space, we call it NASA, the National Aeronautics and Space Administration, came up with a space mission primarily to explore the moon and put people on the moon. And then it is the Apollo 11 that the first man managed to land on the moon. That space mission was conducted by Neil Armstrong and Buzz Aldrin, and they landed on the moon on July 20, 1969. That was a very remarkable achievement. And in the words of Neil Armstrong, he said, and I quote, "That's one small step for a man and one giant leap for mankind." So he understood that what they had done at that point in time has taken humanity to another level of thinking, accomplishment, achievement, curiosity forever. So that brings us to the idea of the old space economy. You see, all the brief history that I've described up to this point, I've used those slides in order to make a proper context to give a distinction between what should have been the old space economy and what is the new space economy that exists around us. So, as you've heard in my area talk, the old space the old space race or the space competition that was existing was mainly between Russia and the United States. And mainly, the context was that these were government funded programs. Okay, so on one end, NASA was advancing all sorts of programs for the United States government, and Roscosmos was advancing so many space programs for the Soviet Union, which is Russia. And these programs were mainly to deploy satellites for military operations and other scientific research, which was targeted for government ambitions. Of course, there were some private sector at that point in time, but mainly these private sectors were working as contractors for these ambitious government projects. So pretty much anything to do space, it was a project for the government, and then they would find out some contractors who were playing out their business within the context of the contracts. So, in a nutshell, we can say that the old space economy was mainly dominated by these developed worlds, and it was a game that was played by the big pockets, big government agencies with big amounts of monies. So everything to do space at that point in time was really, really expensive. So now that takes us to the paradigm shift that is upon us, the new space economy. Because you see, space exploration and utilization of space has changed ever since the old space economy that was a competitive endeavor between the US and Russia. So the paradigm shift has changed in a way that governments are no longer the key players in the new space economy. We have seen an inflow of so many startups and private entities which are creating their own technologies, designing their own space missions, and deploying these technologies in space for their own use cases and business models. So this has leveraged different innovators and creators across the globe to think about space as a new business. And no wonder we see that today the world's richest man, Elon Musk, has got a space technology company. And those two pictures you've seen there is just to give a contrast to say that a company like SpaceX with its Starship is planning out missions to go to Mars. That's their end game. But initially, the US government was aimed at planning missions to go to the moon. So there are quite a number of aspects that we need to understand about the new space economy. The first aspect of it is commercialization. Now, space is business. That's what it means. It's no longer a government pride. It's business. People can make money out of space. That's what it means. So innovations is the bottom line, and different companies are looking at different technological advancements for deploying new space missions and uh, new strategies for making space more affordable. And there are so many applications that have come along with that. People are now thinking about space tourism. You see, companies like Blue Origin, Virgin Galactic are taking lead. The same way you would move from, let's say, Malawi to Joburg to US to UK in an airplane. People would love to do the same thing in space. That's what we call suborbital travel. And you see, there's a great inflow of startups and small companies with use cases that are profitable and making a big fortune. So, indeed, there are all these aspects about the new space economy and the mindset of how space was back then and how space is in today's world has completely changed. So, the world around us is still very ambitious about space. There are a lot of things that people want to do in space. Okay. Like I said earlier on, SpaceX is developing the Starship in order to start colonizing Mars. Okay. So SpaceX wants us, human beings, to live beyond planet Earth. Okay. So at the very far left there, that Starship getting stacked on the launch pad, ready to launch for test flights. And then on the middle there, that's Virgin Galactic Innovations. They want people to be having honeymoons and all sorts of things in space and come back. So they are quite ambitious about space tourism and space um, suborbital travel. So in this case, they are targeting common um, persons like you and me, people who have no background in many other things to do with astronomy or astrophysics or space science and space exploration, but you just want to become an astronaut by going to space. So these guys probably very soon will get us there. And also of keen interest is the space launch system, which is on the very far right. Um, this is the most ambitious project in space I've ever known because NASA, in collaboration with the European Space Agency and other stakeholders, they want to establish permanent residence on the moon. So they have developed this colossal machine called the Space Launch System, which has got stacks of technologies in it. So they want human beings starting with scientists who can conduct experiments on the moon to permanently live on the moon. So this is an ambitious project, and they already managed to launch the Artemis 1, which is part of this program. And I'm sure the Artemis 2 is right on the way. So you see, why are people interested in space? The reason is simple. Space is quite a big market, okay? A matter of fact, it is supposed to hit a $1 trillion market by 2040, with an average growth rate of 4.5% per year from 2015 to 2040. So it's like an average growth rate of 4.5% for 25 years. It's not a joke. So there are big fortunes that people will make here, and people are interested to be part of this ecosystem and community that is engaged in space business-wise, science-wise, research-wise, in order to advance the ambitions of mankind. The data I have here is quite odd, but I think the context is just quite similar to today's context. But of keen importance is the market, uh, uh, space market by client type, which is on the very far right. You see that as we stand today, about 80% of the market is commercial, all right? Space is no longer dominated by governments, all right? Government and the defense agencies are making pretty much close to 18-20%, but the rest is commercial. So that's why the paradigm shift for the new space economy is very important and relevant to understand, because this presents itself a big opportunity for those who dare to try. However, on the very far left there, you see in space, there are different things that people are doing. Okay, there's satellite communication, there's Earth orbit, which Earth observation rather, which includes remote sensing, and there's navigation systems. Okay, governments are using navigation systems for satellite, missile systems, defense facilities. And then we as human beings are using these navigation systems like GPS to find locations from one place to another and many other things. And satellite communication is enabling us to have satellite phones, to have satellite dish televisions, and many other things. And then the space industry is also bifurcated into different segments. There are specializations within the industry. There are some people who are just focused on manufacturing, others are developing launch vehicles or what you call spacecrafts or rockets. And then there are these people operating ground segments in order to initiate communication to and from a satellite. And also there are companies that are only focusing on developing satellites for specific applications like maybe optical payloads and many other things. And then there are service providers who are leveraging on platforms and technology brought by satellite technologies in order to provide end user services like internet and many other things. So indeed, this represents a big opportunity for startups, okay? Because as a startup, you can support the needs of government, space agencies, like government space programs and many other things. And then you can also develop innovative technologies for private sector and big corporates as well. And then you can also support specific requirements for research. You know, different research institutions have got different research needs. So if you can create solutions for research, the better. And also startups can also support other startups in terms of providing platforms and innovations that needs these emerging and new entrants into the business to get started. And also you can provide end user applications like downlink applications, like software systems that will enable people to make use of space technologies. For instance, if you want to come up with early warning systems, like a software application so that people can easily communicate to each other in times of disaster and stuff like that, and many other applications that consumers can use based on space technologies. So with that, let's now talk about the context of space in Africa. We just have a quick overview. There are a lot more things to discuss about Africa, but I've just picked quite a few things and then end with the context in Malawi. So you see, as of January 2023, the African Union Commission officially inaugurated the African Space Agency in Egypt. So the picture down there is a picture of the building that is hosting the African Space Agency. So this building is located in what they call the Space City of Egypt. So this was quite a milestone because you see the African Union as an entity has got an agenda that we call the Agenda 2063. And they're saying that we are building the Africa we want. So if the African Union is spearheading the establishment of space agencies, it means to say that the Africa we want is indeed the Africa that is technologically advanced in space. However, in Africa, satellite communication is quite dominated by the Western operators, okay? The big fish in the market are Intelsat, we have SES, Telsat, and many other players. And then lately, there are quite a number of satellite operators that are coming on board. Nicomsat in Nigeria and many others. And Africa, I think if we rate Africa in comparison with all other continents, you see that Africa has got the weakest connectivity. We're talking about digital infrastructure and human capital. And there's much less funding coming in Africa in order to improve these things. And there are also some issues to do with regulations. Okay, it's like most African economies are finding it hard to come up with proper regulations in order to move at the speed of light as technology is advancing. And at the same time, you see that Africa, out of the 54 member states, only about 20 countries have managed to have some form of a space program. I'm not trying to say that all these countries have deployed missions to space, but at least have got some form of a space program. And by November 2022, I think at that point in time, about 14 African countries had launched a satellite in space. And as if that's not enough, the continent has got very few space technology startups as compared to all other continents. We can't compare with Asia, we can't compare with Europe, North America, South America, you know. And even few of these startups are developing affordable space technology innovations. Okay, most of these startups in Africa are looking at downlink applications, software systems, and many other things to make use of space data, satellite data, and many other things. But very few are really trying to crack the puzzle to understand orbital mechanics and rocket science and engineering to come up with the next generation of propellants, rockets, satellites, communication systems, 5G, 6G modules. Very few people are interested in doing that. And you may wish to note that in Africa, we do not have active launch site or a launch pad where we can use to launch a rocket. Some are there, I think, in South Africa, the old ones, but they are no longer operational for safe deployments in space. But of keen interest is that Djibouti signed a partnership with a company in Hong Kong to establish the first operational space launch pad in Djibouti. And it's quite a news because it's a $1 billion project for the country. And people are not really interested to develop rocket engines and launch vehicles. I think this is one thing that has made Elon Musk the man of the decade, because you see, SpaceX with the Falcon 9 spacecraft has done so much wonders as a private space entity. And also, the rocket engines that SpaceX is producing are quite novel and very amazing. But we could be thinking about the same things in Africa, because Africa has got potential. We've got cheap labor force. At the same time, we've got some of the raw materials that are needed in order to produce these tech equipment. So the case is no different in Malawi. You see, in Malawi, broadband connectivity was around 22% approximately in 2022. I don't think that number has changed a lot. And constantly, we've been hit by all sorts of natural disasters, come heat waves, droughts, extreme weathers, floods, you name it. Okay? And all of these issues, the problems we're facing in Malawi in terms of digital proliferation of digital connectivity and natural disasters have got some bearing on what space technologies can do. And as it stands, as it stood by 28th September 2022, Malawi only had plans to think about space programs and potentially come up with a space agency. But the narrative has changed ever since, I think, somewhere around April in 2063, where the government appointed a special task force to look at the establishment of the Malawi Space Agency. But you see, some of these things are quite common in Africa. But still, a good number of African countries are doing nothing in space, and quite everyone is being affected by natural disasters, especially the ones caused by climate, like floods, heavy rains, and stuff like that, extreme heat. So let's look at some of the most recent developments as regards to space in Malawi. You see, in August 2022, the first space technology startup, Daka Space Technologies, was registered in Malawi. And a few months down the line, in November the same year, Malawi held a first space conference. And as of April 2023, a task force was appointed that looks at the establishment of the Malawi Space Agency by 2025. So fingers are crossed. By next year, Malawi should have an operational space agency. And as of October 2023, Malawi held its second space conference, and I was privileged to be one of the guest speakers at the conference. And then just recently, in February 2024, the chair of the Malawi Space Agency Task Force, Mrs. Tandikiri Mvundula, was elected as the vice president of the African Space Council. So indeed, we can see that there are some baby steps and some big steps that have been taken by Malawi as a country towards ambitions in space. So beyond this, I would suggest that Malawi really needs to fast track the establishment of National Space Agency. This is very, very much needed. And then after that, or along with that, clear-cut policies and regulations should be formulated, and these have to be enabling, knowing that we are a new entrant into the industry. And once these two have been achieved, then Malawi should think about developing a space program. I would suggest an Earth observation program where we could look at maybe disaster risk management and early warning systems to safeguard lives in terms of natural disasters, stuff like that. And also, Malawi should now start to dedicate resources for space technology startups because companies and startups like Daka Space Technologies really need a cushion from the government. And to grow further as a country, I think we need to leverage regional partnerships. First of all, I think we need to have an understanding with the African Space Agency and also some of the notable key players, some state agencies. Of key importance is the South African National Space Agency, SANSA. It's doing quite remarkable things. And also we can look at partnerships as a country with the private space sector, both locally and internationally. I think we all saw it in the news that Zimbabwe managed to launch their satellite through collaborations in the US. So let us wind up this talk by looking at space applications. And because this subject is quite extensive, I would rather let us focus on satellite applications because there's so many things going on in space beyond satellites that are of relevancy to our day-to-day applications. So you see, naturally, when we talk about satellites, we want to talk about the artificial satellites because the Earth has got its own natural satellite and we call it the moon. That's our natural satellite. But when we say satellite, in this particular case, we want to talk about the man-made objects that have been put in space to move around some sort of celestial body. So it could move around a planet, could move around a moon, and many other things. And these satellites, they come in different sizes, shapes, and dimensions. And of key importance is the emergence of what we call the cube satellite. And this is one of the things that Africans can leverage on, and particularly in Malawi, we can leverage on in order to start deploying low-cost space missions. Because back in the days, space missions were very costly because these objects were very heavy, huge, colossal machines, so to say, suspended in space. However, these days you can have small satellites, medium satellites, cube satellites, nano satellites, mini satellites, all the way to the large category of satellites, especially the GPS satellites are very large, deployed in the geostationary orbits. The size of the satellite also determines what exactly the satellite can do and what type of services or what type of payloads can be embedded on the satellite. So in Malawi, I think we can look at some of the use cases that satellite technology can give us for social and economic development. There are quite a number of them, but I've summarized maybe in 2 or 3 slides. The first thing that we have to look at is agriculture and food security. You see, the world is evolving, and when you see the world is changing, one critical thing we have to pay attention is that the population of the world is also growing. Okay? I'll just give an example. In 1900, the population of the world was about, let's say, 1 billion people. But here we are just close to 8 billion people. So within 120 years, the population of the world has grown 8 times. So satellite technologies, particularly the ones that are going to safeguard food for everyone, are going to be very important. And for that fact, satellite technologies are being used to monitor crop growth and many other things, including what we call precision agriculture, where you're precisely determining which land based on remote sensing technologies and which crops and which seed types and whatever decisions have got to be made by the ministries of agriculture in order to determine where exactly you can plant or grow something for it to succeed and produce more. Beyond agriculture, we can also look at natural resource management. You see, the concept of sustainability in general is to think about how do we use what we have today so that the next generation should also have a good portion of what we have. So satellite technologies can also help us to think about how do we conserve the environment, the forest and everything, and also how do we monitor and manage rare resources which are constantly being mined. Satellite also gives us good access to the digital world, particularly through the internet. And with satellite, we've seen that, for instance, SpaceX has done quite a remarkable work here. They are providing connectivity across the globe using small satellites. And then they are demonstrating also high-speed communication using their new satellite technologies. So this is what is going to shape the new world altogether. It's not just about the new space economy. Actually, it's about the next generation. Satellite data can also help us to manage disasters. We can predict using models, though predictive power is still limited. And also, we can manage to have early warning system in order to make sure that people are safeguarded from natural disasters and many other things. And then we can also determine what is likely to happen with the weather and many other things, space weather monitoring systems using these satellite technologies, which is very crucial and important for agriculture and also uh, for our safety and our daily livelihoods. And of late, we know that all across the world, the need for healthy care and healthy specialists is on the rise. But not everyone can manage to meet a doctor. So this is where satellite technologies can enable people living in rural and remote areas to meet virtually with doctors and telecenters and stuff like that in order to get assistance without necessarily paying hefty costs to book in-person appointments. At the same time, with the inflow of epidemics like the COVID-19 and many other things, we can also leverage on satellite data to monitor human movement and to see how that translates to uh, uh, the epidemics being spread from one area to another. And also, you see, the places that we stay, be it in the cities the CBDs, our households are well properly demarcated by the governments that we come from. And the government make use of space technologies like satellite images and many other things in order to determine which areas can be habitable, which areas can be used for agriculture, which areas can be safeguarded for biodiversity, and which areas can be used for urban city planning and many other things. So satellite technologies indeed are going to help us to achieve that feat. So particularly for Malawi, if we leverage our own deployments of satellites and also to come up with downlink applications based on the already existing satellite data, we can be able to make a difference on how we plan for the future. Of key importance is education and research. Satellites are not only sent to give us a means to communicate from one geolocation to another, or to have some sort of payload that is mapping space weather and determining fluctuations in climate change and stuff like that. No. We can also deploy satellites in order to do some scientific research. The world has collaborated for a number of years through the International Space Station that is deployed 400 kilometers away from the Earth's ground, where scientists day in, day out are conducting different experiments. It is quite amazing and fascinating to see that even biological agents have been tested in the space environment. And also, space can be used for national security. You see, these days they say that if you are a superpower, you have to have uh, uh, control over the water, control over the land, control over the air, and control over space. So it's like the criteria for a superpower has even gone to the dimension of space. However, we're not trying to say that Malawi should become a superpower, but all we're trying to say is that through satellite technologies and many space-based deployments, we can enhance national security. We can control who comes in and out of the country. And then we can also properly monitor our airspace in case it is being encroached by unnecessary aircrafts and airplanes. And then we can also do what we call environmental monitoring. Okay. We can monitor the status quo of our power grids. You know, power is everything. We can't stay without power. The fact that we have this webinar, it means there's power somewhere connected to all of us. And then we can use satellite to advance our transportation systems. You may wish to note that the aircrafts that we use to travel from one place to another use a lot of satellite technologies, including GPS. And also we can use satellites to monitor our immediate environment in terms of waste management. So before we end, I just want to excite the minds of our youngsters who have joined this webinar. I just wanted to talk a little bit about careers in space. 2 slides would be enough for this. You see, probably you as a student, you might be asking yourself, what is it that you can take as a prerequisite to do something about space or to do something in space? As you may know, my background is in physics. That is not a coincidence that I am also pioneering space in Malawi. Because if you really want to think about space, the first thing you need to think about is physics. Of course, that also comes along with all sorts of natural sciences like biology, chemistry. and also mathematics plays a big role. You need to have a good sense of geography. And back in the days, most of the astronauts were actually those who had been trained to be pilots. So you cannot become a pilot if you don't have a good sense of geography. And also because in space we are designing rockets, rocket engines. If you're a rocket scientist, you also need to have probably a good background in technical drawing if you really want to be a designer of these spacecrafts. So there are so many professions in space, including rocket science, aerospace engineering, which includes aeronautics and astronautics. And you can become an astrophysicist, or you can study astrophysics. You can also become a flight controller if you're good with computer science and many other things like IT and ICT. Because when we're sending rockets to space, we are using the ground segments to communicate to the rocket so that it takes a precise trajectory for orbital deployments. You can also become a biochemist, which is a sandwich between biology and chemistry, because you see, human beings have got to exist in space. So you need to have a better understanding of what we call environmental control and life support systems. So that's why astronauts usually use their spacesuits to execute spacewalks in space. Those are equipments that have been developed by scientists, medical experts, and many other technologists in order to support life in space. At the same time, the gadgets we use on Earth ordinarily cannot work with the same efficiency and with the same operational lifespans in space. We need special materials, special electronics, special materials that we can use for things like radiation shielding uh, and many other things. Also, as materials engineers, you can develop the next generation of um, solar panels, which are very efficient, so that the operational lifespan of satellites and space missions can be lengthened. So that marks the end of my talk. And at this moment, I invite some questions and comments. Thank you.
That was an enlightening presentation on space economy. Thank you, Mr. Daka. In the moment, we're going to have a Q&A session, so kindly request you to adhere the following guidelines. Please ensure that your inquiry is formulated as a concise and genuine question, and questions should not articulate within the time frame of 20 seconds. To participate, please utilize a visual hand raising feature. Once recognized in the queue, your microphone will be unmuted in the sequence and you'll be invited to pose your question. Questions in the Q&A box will be selected according to relevance, importance, and popularity, and they'll all be addressed here. Questions that cannot be addressed during the session, they will be compiled and answered in a follow-up email or on our social media platforms. So, as I mention your name, when you raise your hand, please take the floor. Wangani Makuta, you can now ask your question.
Okay, good evening. I wanted to ask about if Malawi was a superpower, how how is space technologies utilizing space to uh, boost up communication?
Can I pick that one?
Yes, you can.
Great. First of all, we're not trying to say that uh, Malawi and the rest of the African uh, economies have got to have superpower ambitions. We really do not want to advocate for that kind of old space race. Okay, but at the same time, you see, you can agree with me that every time you walk around in rural areas, you see that it is easy to communicate maybe with your grandma and your siblings. Um, Mostly because the terrestrial networks, the transmitter towers that telecommunication companies are deploying on ground, on Earth, cannot reach everywhere. And at the same time, you see that in rural areas, you see that sometimes you don't have as much people to create a business model where you can deploy a dedicated um, mobile communication tower for that. So we are proposing that space technologies are enablers for this fact to say we may have a satellite dedicated for specific communications. Let's say if you want to extend internet connectivity in places where people don't have internet, then you can leverage on satellite communication and satellite deployments in order to deploy satellite that is going to provide connectivity in those particular rural areas and remote areas. You may also wish to note that this is not only a problem for rural and remote areas. The problem also extends to maritime um, transportation. When you're sailing on the sea, there are no transmitter towers on the sea. You don't know where you're going. You see, 70% of the earth is just full of water. Okay, the surface, 70% of it is full of water. How would you know that where you're going in the right direction? Then you need to use these satellite technologies. So if you want to advance many frontiers of today's life and the next generation, I think space technologies are going to be an integral part of that endeavor. Thank you.
Okay, thanks for the response. It's well understood. I also wanted to ask, uh, because as an engineer myself, I've also seen that space technologies have been used. But then I've taken an example of Elon Musk's company, SpaceX. SpaceX, they produce, they're offering internet, high speed internet. But then also, as time goes, eventually we'll start using satellite technology for internet and other communications. So how do you plan to bridge the gap of internet cost with bridge the gap of internet cost? Because when you are generating from space, what I know is that it's going to be very expensive. So how are you going to bridge the gap of cost so to make data more affordable to people? Yes, that's what I mean.
All right. Thank you so much for your curiosity. You see, I'll attempt to answer that in a very broad sense. What is it that makes space very expensive? All right. You see, like I said, most of the players in the space technology industry are based and hosted in the developed world. Okay. So Africa has got a particular advantage toward that because we have very much affordable workforce, right? And at the same time, we've got access to some of the raw materials that are needed to do these things. So, from the perspective of low cost labor and affordability of uh, materials, we are already reducing the cost. But at the same time, what we're trying to do is that we want to make sure that even the development process, okay, starting from the design, the production line, the whole assembly and manufacturing process has got to be thought about innovatively in order to eliminate unnecessary costs. Okay. And you see, a lot of companies are already developing rockets that can deploy these space-based technologies at very much affordable cost as it is now. And there's even more hope for the future. I'll just give you an example of the same company, SpaceX. Its new rocket, the Starship, it is believed by the time it is fully operational, it will reduce the cost of space deployments by tenfold, like 10 times less than the current amounts that are being uh, incurred by different stakeholders. So you see, the future is brighter. But I think the catch here is that we really need to think ambitiously. At the same time, we really need to make use of this opportunity because the window is really, really shrinking. The way less competitive space was a few years ago is not the same way now. If someone is starting up now, they have to level their game up and they have to really know what they're trying to do. But by the end of the day, we are going to be able to achieve all of this if we really have commitment from our governments, including the Malawi government, and also if we have uh, commitments in our respective startups and space technology companies. Thank you.
Um, James Frank.
Okay, so I have two questions. My first question is what are some of the notable universities or institutions known for offering high quality education in space technology? And number two is how can students stay updated on the latest developments and the trends in space technologies throughout their education and beyond? Thank you.
Thank you for your question. You see, there are quite a number of institutions across the world uh, producing um, good students in space-related initiatives, space programs, space research, and many things. Uh, but I think, as for Malawi, to begin with, uh, we don't have any institution which is focusing on space, as we say. They could have modules that have to do with remote sensing and stuff like that, but not necessarily in the context of building a space program. But of key importance for Malawi is that I think the task force for the Malawi Space Agency last year, I think that was late last year, they held a stakeholder consultation meeting with the academia, with all the big universities and research institutions to see how is it that the syllabus and curriculum can be moderated and come up with content that creates new programs that are targeting space careers. But across the world, there's so many other programs. Okay, you can study in Egypt, you can study in in South Africa, and you can study in the UK, in the US, and Singapore also is doing a remarkable work. Speak about India. India just launched the Chandrayaan-3 mission, which was remarkable, successful on the south pole of the moon. So even Japan, the Japanese space agency, Japanese aerospace agency, and many other places, they are doing quite remarkable.
Jimmy Mature, you can now ask your question.
Okay, good evening. Earlier you mentioned that space and satellite data can be applied in fields such as early warning systems, risk management. However, sometimes these require, they rely on other fields such as the running of climate models. Those can assist a lot in early warning systems. However, Malawi's computer infrastructure is not that good. So in fields like this, how will you go about providing these applications of space in fields that rely on other factors?
Thank you very much for your question. You see, the issue is about how best can we start, or what is it that we can start and succeed with. Okay. There are a lot of technocrats that are involved when it comes to anything to do with space. Even from the traditional approach where people are launching a rocket, you see that there are chemical engineers trying to come up with propellants. There are mechanical engineers, technicians, IT experts, computer programmers, you name it, material scientists, nanotechnologists. The list is endless, all the way to astrophysicists, aerospace engineers. Okay, so space is multidisciplinary in itself. But then to answer the question, how best can we start in the event that we don't have all that at hand? I think the issue of collaboration is quite key, because if we want to deploy missions in space, then we have to identify partners for a start. Okay, I'll give you an example. Yeah, even us at Daka Space Technologies, we've got some partners in Singapore and some partners in Italy. We cannot afford to do everything by ourselves on the word go, otherwise it's going to take us decades. Okay, but how do we start quickly, faster? Then we have to leverage on collaboration. So in areas that you're strong at, you can find your own local expertise. But in areas that you know that you cannot suffice, then you need to identify partners, come up with memorandum of understandings which are beneficial mutually in both parties, and then you can kickstart. Thank you.
Thank you very much for your response. I also have another question which related to how you are pushing for space education in universities rather than just secondary schools or primary schools to sensitize younger people into understanding how relevant and important space science and space exploration is.
Thank you for your question. You see, the thing is that particularly for the Malawi Space Stars, we are targeting the next generation of space leaders. All right. And the next generation is not you and me. The next generation are the youngsters who are still in school, the ones who have not even made up their minds on what careers they can pursue. All right. So how do you influence decision making for the next generation? Then you have to reach out to the ground roots. So in this particular case, that's why we are focusing on secondary schools, so that as young students are graduating from their high schools, they can think about careers that are related to space and then get inspired to become an expert in a space-related field. But at the same time, we're not saying that universities are not relevant. With universities, what we're doing is that we want to partner with universities from a research point of view. We understand there's quite good expertise in terms of research expertise and also some sort of innovation that the universities can bring on the table. So mainly with universities, that's what we want to do. But at the same time, we can also inspire technologists and engineers in the universities through events like these, so that they may also think about how do they translate their respective fields into something to do with space. Okay, so for instance, if you're a computer scientist, if you want to come up with programs for launching and starting rocket engines, or programs for coming up with applications for space data and everything else, then you can try to align your primary career, which is computer science, into a specific field that targets space. Thank you.
All right, thank you very much.
William Kapika, you can now take the floor.
All right. Thank you so much, Patricia. And thank you so much, Dr. Daka, for the kind presentations that are presented. I've seen that you, of course, my question was a bit related to what Jimmy asked me, but now that part of it has been answered, now I'm much more interested to look at the initiative that you have taken, launching the Malawi Space Stars. I've seen you launching the Malawi Space Stars in some of the secondary schools within Malawi. Now I'm looking at the context of our schools, the background. We don't go much on the hands-on kind of. So we mostly draw much on the theory part of the science than on the practical part of science. But now I understand that your only journey to raise the next generation of scientists much more specifically related to space science or space physics. Can you elaborate more on the potential collaboration between Daka Space Technologies and the education institutions in Malawi, mainly to foster talent development in the space-related field? Thank you.
Thank you so much for your comments and your questions. Eventually, you see, in Malawi, the Ministry of Education is quite serious about space. Okay, as a matter of fact, I think the last time I spoke with the director of science, innovation, and technology in the ministry, Professor Mikeka, he hinted to me that the syllabus for primary and secondary school is actually being considered to include issues to do with space. Okay, so right from primary school, students should be able to learn about satellites, space, and everything beyond the traditional solar system and everything else. Yeah, and at the same time, you see, the Malawi Space Stars is just one of the so many ambitions and initiatives that we are trying to advance. So particularly the Malawi Space Stars has got a specific context in which we want to reach out, just an awareness. But what we intend to do is that I think in our value proposition, I did mention to say we want to develop space manufacturing facilities and advance cutting-edge space research. This is part of the puzzle that you're trying to bring forward, to say beyond exciting someone's curiosity in space, what else can they touch, see, and experiment with? So we want to build those facilities in Malawi, and there are some stakeholders and partners that we are still identifying the possibilities there. Is just a matter of time that by the end of the day we'll be able to do that, and then we'll have student exchange programs, internships, where university students and new graduates can come at Daka Space Technologies and then get a glimpse about space research and space exploration. But also, in addition to that, you see, we really want to come up with a good model for partnering with international institutions. I think I just spoke it in passing with one of the representatives from the Royal Academy of Engineering. One thing that we notice is that when we reach out to the students in secondary schools, they want to do a program in space after their studies, but we don't have that in Malawi. So we're thinking about collaborating with other institutions and then provide scholarships to youngsters who are interested, especially undergraduates, who are interested to pursue careers in space. I think that will be coming up soon. And then for your own information, in the next few days, we are also launching what we're calling the Malawi Space Stars community. We want to be communicating space news and space opportunities to a broader audience in Malawi and in Africa, in order for people who are interested in space to get opportunities and to be aware of what's going on in the space industry. Thank you.
Thank you so much. I appreciate it. Very well elaborated. Thank you.
Regrettably, our allocated time for question and answers has concluded. However, any unanswered question will be diligently addressed via follow-up emails or through our social media channels. To stay informed and engaged, I invite you all to please like, subscribe, and follow our social media pages. Additionally, please continue to post the questions on our social platforms using the following hashtags: #DST, #TMSS, and #NewSpaceEcon. Before we conclude everything, I would like to extend the floor to our esteemed speaker for any final remarks.
Patricia, you've been a great and wonderful host. I applaud you for that. And to our audience, I say thank you for your time. Thank you for your curiosity. Let's stay in touch. Like she says, let's keep in touch through our social media and other avenues of communication. And looking forward to talking to you guys now and again. Thank you. Good evening.